This is Professor Slaughter again. Welcome back to Finance 215. And right now we're going to go over the time value of money problems that are in Chapter 5. Now, certainly we're not going to go over everything, but what Chapter 5 does is it basically introduces a more complex time value of money calculation, which involves uneven cash flows and annuities. However, don't let yourself get overwhelmed at this point. If you stick to what we've been doing in the past, which includes drawing the timeline, looking at your formulas, and working with 2 out of the 3 methods to calculate your answers, you shouldn't have any problem. Now, in this video, there will be some embedded videos, and the volume in these embedded videos may not be as clear as I would like it to be. So I will also upload those videos separately so that you can hear them outside the context of the PowerPoint as you're studying. Okay, so first of all, let's talk a little bit about what we're going to be going over in Chapter 5. The first thing is we're going to update the learning objectives for this week. We're going to be looking at the basics of annuities, including computing the future and present values of the annuities. We're going to be looking at cash flows, present values of perpetuities, and as well as computing the interest rate for annuity payments. However, in the video, we're going to stick to really calculating present value and future values, and we're not going to be going into perpetuities or computing the interest. I think there's a sufficient amount of information in the book to guide you through that process. Okay, so let's start it off with just a basic identification of what an annuity actually is. It's a stream of level or frequent cash flows, monthly, annually. Those are the 2 most common. Sometimes they can be weekly, but these annuity payments always occur at the end of the period. And what do I mean by that? Well, if it's a monthly annuity, then the payment's going to be received on the 30th or the 31st. If it's an annual annuity, it's going to be received on December 31st. And these types of annuities that have the payments coming in at the end of the period are called ordinary annuities, or just plain annuities. There is an exception. It's called an annuity due. And when you have an annuity due, the payments come in at the first of the month. So if you had an annuity that was going to pay 1 annual payment in 2015, then that payment would come in on January 1st, 2015, as opposed to December 31st. How do I remember the difference between an annuity and annuity due? Quite simple. If you've got to pay rent, when is the rent due? It's due on the 1st. So an annuity due, the payment's made on the 1st, as opposed to an ordinary annuity, which is made at the end of the month. So technically, from a time value of money perspective, the difference between an annuity and an annuity due is 1 interest period. Okay, so the first thing that we're going to look at the future value of several cash flows. And in this equation, let's see, let me look what we have here. Okay, oops, that's not what I wanted to do. That's not what I wanted to do. It will not let me run back to the beginning. Okay, all the way. Okay, so in this case, we're going to be determining the future value of an annuity due. And it basically receives 3 annuity payments a year, or 3 annual annuity payments. We have the 100 and the 200 and the 300. This is several cash flows that are coming in over a 3-year period. It's not an annuity, sorry. It's just cash flows coming in over a 3-year period. So our total N is going to be 3, our interest rate right here at 7%. The formula that we're going to use is right here. And for those of you who struggle with math, that may look like a very complex formula, but when we apply it, it's pretty straightforward. The section that deals with the $100, we just multiply that 100 times 1 plus the interest rate raised to the n, which we did in Chapter 4 quite easily. So we have 100 times 1.07 raised to the 3rd, and that's because the $100 is going to cash flow over 3 periods. It's going to be held for 3 periods, okay? Then we look at this 125, so we do the same thing. We say, what is our N? And our N in this case is a 2 because it's only going to go from period 1 to period 3, so our N is equal to 2. And then we look at that 150 and we multiply that times 1.07. It's really not necessary to have the 1 there. It's fine if you want to put it there, but it really doesn't have any bearing on the answer. 1 times 1.07, and when we add all of those up, we get this 426.11. So that's it in a nutshell. Let's go into a little bit more detail, just using the timeline. So what am I trying to do here? Okay, so as we discussed in class, this is the present value of the timeline, and this is the future value. Okay, we're going to pull that $150 to year 3, and of course, that's only 1 period. So we have N equals 1. Then we're going to pull that 125 into the same period, and this is going to be held from period 1 to period 3. So that's 2 N. So N is equal to 2 here. And then we're going to look separately at this $100 payment, again, pulling it to year 3, which means that this is going to get the full treatment, the full N equals 3, because that $100 will be in this cash flow, held in this cash flow for a total of 3 years. We've got the 1 and the 2 and the 3. All right, so we just looked at the formula in the previous slide, so I won't go over that again, but we end up, for the analysis of the $100, we end up with 122.50 when we apply the formula. And then when we analyze the 125 with N equals 2, we end up with 143.11. And then when we analyze the 150 for just 1 year, it's only going to receive interest for 1 year, we end up with $160.50. Ultimately, what we're going to do is we're going to add all 3 of these together, which is going to give you $426.11. And so if we wanted to work this through manually, meaning we're not going to use the time value of money keys, I'd set up the timeline, manually run it through the calculator, and then set it up like this. But if we're going to use the formula, then and not use the timeline, which I don't recommend, we would basically just feed it through the formula. Where's my cursor? There it is. Feed it through this formula right here, which would ultimately give us the same answer of 426.11. Okay, so this is one of the embedded videos that's involved in this presentation that I'm going through. The volume may not be very good. I hope we'll be able to see it and understand it, but if for some reason it doesn't come out very well, I will be offering these as a separate link in Blackboard for you to watch outside the context of the PowerPoint presentation. So we'll go ahead and launch this. This is going to tell you how to enter your information for this problem into the calculator. Okay, so if we're going to strictly rely upon our financial calculator to solve this problem, then basically what we need to do is we need to calculate the future value of each of the 3 deposits in this problem. So I'm just doing this to help you learn how to enter the information into the Texas Instruments BA2 Plus. Okay, so the first thing you're going to do is, since your N is equal to 3, make 3 N. And then 7% interest, so it's 7 I over Y. And if you'll remember on the BA2 Plus, either the present value of the payment or the future value has to be entered as a negative number. Since we don't have a payment and we're calculating future value, then this forces us to enter the present value as a negative number. So the present value is $100, and so we have that plus minus key and PV. There'll be no payments. And then we're going to compute the future value, which is compute FV, which gives us 122.50. And so we write down that answer, and then we do the next calculation. And you'll notice every time I do a time value of money calculation, I completely clear out my calculator. It's just a force of habit. Okay, so in the next payment, we're going to have $125, and we're going to hold that for 2 periods. So we have 2 in, same interest rate of 7 as interest IOY. Present value is now 125 because that's the payment that we're analyzing. So we put that as a negative number into present value. There'll be no additional payments, and then we calculate future value. We end up with a future value of $143.1125 or $143.11. Okay, so on the last of the deposits, $150, which will be held for 1 period. We have 1 period, so that's 1 in. Interest rate is the same, 7 I/Y. Enter the present value as a negative number, so we have 150 plus or minus present value, 0 payment, and compute future value for 160.50. And then the last step of this, of course, is to add up all together. Whoops. The last step is to add together all the future values that we calculated. So the first one was 122.50 plus 143.11 plus 160.50, which gives us a future value, total future value of $426.11, $426.11. Okay, so now we're going to, hopefully that came through on the video on this lecture very well. Otherwise, I'll be posting the links up as supplemental links. Okay, so now let's look at the future value of an annuity. Now, this is an annual annuity, and you can tell that because the payments are coming in once a year at $100. And let me change my color over here. All right, and so the formula that we're going to use is the future value of an annuity, this right here. We're going to take the payment that we receive, which is that $100, and we're going to multiply it by this entire formula. Now, the one thing that I don't like about the way this formula is represented is that it's not very clear when you have people with math deficiencies that may be struggling to see what we're doing here. So if you want to think about this as a bracket right here and right here. So you're taking that payment and you are multiplying that payment by the entire calculation that is inside these brackets. Okay, so first of all, let's look at the timeline. So what are we doing? We are going to be bringing this into future value, right? So these are coming in at the end of the period. So this is a 5-year annuity. So this $100 right here isn't going to earn any interest whatsoever because it's coming in at the end of the 5th year. So we're just going to add that in as normal. Now this is supposed to be our target answer that we're looking for, 586.66, but let's see if it's true. So we're going to pull this $100 forward. And we know that in this case, our n is going to be equal to 1. We know that this next $100 is going to be calculated through with an n equals 2, right? Because there's actually 2 periods, 3 to 4 and 4 to 5. Okay, then we're going to analyze the next $100 payment, and we're going to total that up for the end, and that n is going to be 3. And then we're going to look at this final $100 payment. They came in at the end of the 1st year, or the end of year 0, if you want to look at it like that. So that's going to be a total of 1, 2, 3, 4 ends in the problem. Okay, so in this way that we can calculate this using the future value calculations, we can calculate each one and add them together. But for the sake of simplicity, I want you to take a look at this calculation, 586.67. Okay, hold on. Let's go back. Let's finish up this timeline, okay? If we were just to dedicate ourselves to using our typical future value formula, what would we do? We would take future value equals the payment times 1 plus I raised to the nth, okay? And our I is 8%. So when I go through and I calculate all of this up manually, when I calculate the first $100 payment, well, we'll start with 1.08 raised to the 1 times 100. We should get $8. Okay, so we're going to do 1.08 raised to the 1, which we don't really need to do, times 100. This is going to be 108. Okay, so let's look at this second $100. So it's going to be 1.08 raised to the 2 times 100. And that is going to give us, I'm looking for my pointer, okay, 11640. Okay. Then we look at this third 100, doing the same thing, 1.08 raised to the n equals 3 times 100. That gives us an answer here on this $100 payment. Whoops. Let's clean this up a little bit. It's going to give us 125.71. And then for the last problem, we're going to take 1.08 raised to the 4 times that last $100 payment at 136.04. If we round it, we're going to get 05. So probably our final calculation is going to be a little bit off from what we're looking for. Now, I want to caution you on something. We cannot forget that when we go to add all these numbers together, we need to make sure that we add this 100 and all of these together, because just because we're not earning any interest on this 100 right here doesn't mean we're not going to include it in the annuity payout. Okay, so when we add all these together, 100 plus 108 plus $116.40 plus 125.71 plus 136.04, we end up with 580. I ended up with 586. 586.15. Now there's a possibility that we've got some rounding issues in there. I know our target is 586.66. Let me one last time just go ahead and make sure I haven't made any obvious calculation errors. Yeah, I'm getting 586.15 on this, but we did this manually. Okay, so let's move over to the next slide. Now, if we do this applying this formula here, which is this formula is a lot simpler, and we can use this formula because we have a steady payment of $100. So what we do is we load up all our variables. Our I is 8%, our N is 5, and our I here is also 8%, 0.08, and we have our payment. So if you might want to stop this video, try to work through this problem. This is the problem that you want to work through. and make sure that you get the same answer that I do, 586.67, which is closer to being to the answer that we're looking for. Okay, again, we have another video here. This is going to show you how to solve this same problem with a period of 5 years, 8% interest, no present value, and a steady stream of $100 payments. We'll show you how to load it into your calculator. So we'll take a look at this, and I'm feeling hopeful now that these videos are going to play quite well in this PowerPoint. Now this is just a quick video to help you enter this particular problem into the calculator. So you're going to hit 5 and N, 8 and I over Y, 0 and PV. And since the $100 payment is the only thing that we're entering between the PV, the payment, and the future value, we're going to make that the negative number and enter that into payment. And then we're going to hit compute future value, and that should give us the 586.66 that we're looking for in this equation. Okay, so that wraps up the 3 different ways on how to solve the cash flow. The problem, I'm so sorry. This should give you the 3 ways, the formula, the timeline, and the calculator for solving the steady payments of $100 each coming in every year, 8% interest over a 5-year period. So now we're going to look at the present value of cash flows. And again, when we look at that formula, it looks pretty complicated, right? When we're looking at this formula right here. But in actuality, we've been doing the whole thing. We've been doing this all along. So we've got our formula here that we can use. We've got our timeline. And we have our calculator set up here. Now, I know this is new. This is potentially new to you. And so I will have a mini video to show you how to set this up. But you'll notice the big difference in this one is the fact that each one of these payments, each payment is different, and we're going toward present value instead of toward future value. So let's look at this. What are we doing? Obviously, there's nothing that's going to be discounted on this first $100, but we're definitely going to be discounting this 125, and we're going to be discounting this 150. And I'm right-handed, so when I have to draw lines to the left, I do a miserable, miserable job of it. I can at least try to do that one a little bit better. Maybe I can get my lines going to the left just a little straighter. It's better, I guess. Okay, so we have here, we know that our N is equal to 1 here because we're only covering 1 period. And then we know that our N is equal to 2 here because we are covering 2 periods. Okay. So we're going to come up with calculations for both of these. And the formula that we're going to choose to work with here is the calculation of present value, which is equal to future value divided by 1 plus the interest rate raised to the nth, which we've already done. But then if we add it again, because we need 1 for the $100, we need 1 for the $125, and then we need a third one for the $150. So the formula is going to start looking like this, and this looks pathetic too. I'm practicing. Hopefully by the end of the semester I will have mastered this writing style. So let's try this again. 1 plus I raised to the nth. Okay. All right, so this is actually the formula that we're going to be using. And if you work through this formula, and I'm not going to do it here, but if we work through this formula, we end up with $100. which is right because we're not discounting this first $100 at all. And then we're looking for the present value of the second payment of 125, and that's going to give you something around 116.82. I did carry out my numbers to 6 decimals places, but you know I'd recommend that you go at least 4. And then the future value of the the present value of the 150. You should come up with something that's around 101 or 102. And then when you add all of those together, you're going to end up with a final answer somewhere around 347.84. You know, within a penny or so of 347.84. And that's how we would attack this problem with a timeline. Okay, now if we're just going to go ahead and deal with the formula, and there's certainly, if you've got a good foundation in math, there's nothing wrong with using the formula, but if you look at what we're doing the same thing that we did with the timeline. We're adding in the $100. This portion of it represents the calculation on the $125 payment. This calculation represents the analysis on the $150 payment. We're going to add everything together, the 100 and the 116 and the 131, to come up with a total of 347.84. Again, I recommend that you put a timeline with every single one of your problems. Okay, now this video is a little bit longer than the other videos that we have looked at. You need to pay very, very close attention to your keystrokes on doing with working with the cash flow register, so you do not lose track of what you're doing. So I'm going to switch this video over, and we will, but again, pay very, very close attention to this.
To solve this problem with the VA2 Plus, we are going to have to work with the cash flow register function in the calculator. I cannot stress to you enough how important it is that you pay very, very, very close attention to the entry of the keystrokes for solving this problem, because any sort of deviation from what the calculator will accept will make it nearly impossible for you to solve this problem and larger problems as well. So the first thing I want you to do is we're going to make sure that in your calculator the cash flow register is clear. So the way we're going to check that is we're going to hit the CF key, and if you have anything in there but a 0, then we need to clear it out. So cash flow 0 in my calculator is 100, so I need to clear out my calculator. And you can also use this down arrow key and check your register. And if you've got anything but 1s and 0s popping up, then you need to clear it out. And the way you clear it out is you hit second on clear work. And then check your cash flow register again. Make sure everything is coming up 0s. Okay. And then I'll just go ahead and hit that clear button on the lower left-hand side several times. Okay, so to enter this into your calculator for solving, we're going to go very slow, very meticulously through this process, and if you don't get the right answer, then you need to listen to this video again to make sure that you caught all the steps. So the first thing we do is we hit the cash flow key, CF. And you'll notice on the screen it says CF0. So in this problem, 100 is our first cash flow. You're going to enter 100, and then you're going to hit the enter key up here at the top. Then you're going to hit the down arrow key, which is going to take you to CO1, which is your first cash flow. So it's 125 in this example. Again, you want to hit the enter. And then when you hit the down arrow key this time, you're going to see an FO1, which means frequency, and we won't be using that in this problem. So you're going to scroll, it should say 1, and you're going to just hit that down arrow key and scroll through it again until you see CO2. You're going to enter your next cash flow, which is 150, and hit enter. Then you're going to hit that down arrow to take you to FO2. Now the next thing you're going to do is you are going to hit the NPV key, which is going to take you to I, the interest rate. So in this problem, the interest rate is 7. And then we are going to hit enter. And then you're going to scroll down, which is going to reveal the NPV key, which is the net present value entry. And then you're going to hit compute. And you should get $347 and basically 84 cents. So if you do not get that answer, that means you've set something up incorrectly. So then what you would need to do is clear out your work, go back to your cash flow key, and since you've got data in your cash flow register now, you would hit the second and the clear work key to clear it all out and start over.
Okay, so hopefully that video will help you set up your cash flow registers in your calculator. If you have any problems, this is something that can be a bit challenging, but if you have any problems, let me know and I'll try to help you out if you are using the BA2 Plus, because that's the calculator with which I'm most familiar. Okay, so this kind of wraps up this video for Chapter 5. This is kind of just a little encouragement here that the ability to go the extra mile lies between your ears. So keep working on this stuff. We'll go over things in class. You can post any questions that you have you can text me and ask me questions, or you can also email me, or just save your questions for class and we'll post them on the board.